folks, so we are starting with number 37 in the review. So let's start with our horizontal asymptote rules. Is this top heavy, bottom heavy, or same? Bottom heavy. So again, you don't have to write that on the test, but just note that because the bottom has a higher degree, that is why we know we're going to have a horizontal asymptote at y equals 0. So horizontal asymptote at y equals 0. So we are going to draw that in as a dashed line going through 0. Now, vertical asymptotes and holes are the ones that come from denominator restrictions. So denom restrictions. So do we have any restrictions on x in the denominator? I would start by factoring the denominator. We've got difference of squares, so x plus 6, x minus 6. So what are the two things that x can't be equal to? 6 and negative 6. And again, it's important to note that this one goes with that factor and this one goes with that factor because that makes a difference as far as whether you can cancel the factor or not. So these are my restrictions. It will be a whole if the factor cancels. It will be a vertical asymptote if it doesn't cancel. So those two factors, x plus 6 and x minus 6, do they cancel? Nope, there is nothing I can cross off with on the top of this fraction, so I am stuck with those factors, so that means these are both going to be vertical asymptotes.
So the vertical asymptote is negative 6 and 6?
Mm-hmm. So vertical asymptote at x equals negative 6 and x equals 6. You have to include the variables with these equations. Horizontal lines are y equals equations. Vertical lines are x equals equations. That goes all the way back to Vex and Hay from Unit 1. So we're going to draw that in as a vertical line at negative 6. A vertical line at positive 6. And you can either leave the holes blank or put a line through that because we will only have those restrictions as vertical asymptotes for this one. Now for the y-intercept, that is going to be a number and 0 or 0 and a number? Zero and a number. So y-intercept means number for the y value. So how can we find the y-intercept? We're going to plug in 0 for x. So f of x, or y, equals 3 times 0 over 0 squared minus 36. You can use the factored form if you want, but standard form's a little bit easier for the y-intercept. So SF for the y-intercept. And we get 0 over negative 36, which is 0. Ouch. 0. So that means our y-intercept is at 0, 0. No, 1 over 36 is 36.
No, 36 over 1.
36 over 1 is 36. All right, folks, now 0, 0 is the y-intercept. It's also going to be one of our x-intercepts, but just in case there's more, we do need to solve for them. For the zeros, we want to make sure we are using factored form and the canceled form if that applies. Now, we didn't have any cancellation of the factors here, so we don't have to worry about that on this problem, but just make sure your x-intercepts don't violate any of those restrictions on x. It is best if you use that factored canceled form. So zeros are the x-intercept, which are a number and 0. So I'm going to take 0 and plug it in for the y value. So 0 in for the y value. We get 0 equals 3x over x plus 6 x minus 6. Oops, you guys can't see that. How am I going to solve this equation for x? Ew, a fraction. How do we get rid of that fraction?
You times it.
Times it. So we're going to multiply both sides by
By 3.
x plus 6, x minus 6, plus 6. Goodbye. All that junk times 0 is 0.
It's just going to be 0.
And it is 0. Very anticlimactic because we already kind of knew that 0, 0 was a y-intercept, so 0, 0 is an x-intercept as well. So this is exactly how it's going to be set up on the test. You have to fill in the blocks of information. You have to graph those pieces of information. And then our final step is to use our calculator. Now, folks, when we type this in on our calculator, what key thing do we need to remember to use? Parentheses. I would use the original equation just in case you goof somewhere with your factoring. So type that into the y equals 3x divided by parentheses x squared minus 36. And this shows you what is happening through those key features that we found exactly. So swoosh, swoosh. Making sure you draw arrows on all of those pieces. It should not look fragmented like it is on your calculator. We should have those continuous arrows going all the way to infinity. Questions on those ones? On your own, get as far as you can on number 38. All right, folks, let's start with the horizontal asymptotes on this one. Top heavy, bottom heavy, same. Same. We've got 2x squared and 1x squared. Since it is same, we take the ratio of the leading coefficients. So we will have a horizontal asymptote at y equals 2. So 2 on the top, 1 on the bottom. 2 over 1. Ratio of the leading coefficients.
So you just like divide, right?
Mm-hmm. So 2x squared over 1x squared is 2. So there's our first key feature. Now, vertical asymptotes in the wholes, those come from the denominator restrictions. What should we probably do first? Factor. What's the first thing we check for when we're factoring? GCF. GCF on the top first. Factor it all the way. See if you can figure out the restrictions.
There's 2 on this one. You factor both of them?
Start with the top.
Yeah, factor both. Factor all the things. Gotta factor all the things because we have to figure out if they're going to cancel or not.
That was fun.
That was me. Oh, and then you see you can cancel it out.
What if like some of them cancel it?
Careful on that top one. Sometimes students will try to factor it as x plus 6 and x minus 1. That does give you the sum of 5, but it does not give you the product of positive 6 that you need. So this is what the full factorization of the top looks like. And x plus 2, x plus 1. So let's start with our denominator restrictions. What can't x be equal to? -2, because that would make it dividing by 0, thus undefined. And x also cannot be equal to -1. Do either of those factors cancel? Quote unquote cancel. The x plus 2 factor, quote unquote, cancels. Remember, quote unquote, because it doesn't actually cancel because 0 over 0 is not equal to 1. But because it kind of cancels, we will have a whole at that x value. This factor does not cancel, so that will be a vertical asymptote. So we have a vertical asymptote at x equals -1 and a whole at x equals -2. Now, the vertical asymptote we can definitely graph, but the whole we're going to have to wait until we see our calculator sketch. See if you can find the y-intercept and the zeros. Remember, the y-intercept is a little bit easier with standard form. Zeros are a little bit easier with the canceled factored form. And remember to write your answer as a coordinate. What are we getting for the y-intercept? 6. Perfect. So plugging in 0, 0, 0, 0, 0. We get 12 over 2, which is 6. So 0, 6, and plunk it on your graph. So we identify it exactly in the box, and we plot the point exactly on our graph. Next up, the zeros, or the x-intercepts, are a number and 0. Now, using the canceled factored form, we'll say 0 equals 2 times x plus 3 over x plus 1. Does everyone see where that form came from? So this is our factored form right here. And then this is our canceled factored form. So I took out the canceled factor so that I wouldn't use that restriction.
And then it's just gonna be 0. Isn't it? Wait, so when you're solving for the x-intercepts, why do you take out the canceled? Or why do you use the canceled form instead of
So if we didn't take out the canceled form, you would end up getting an x-intercept at -2 and -3. But we have a whole at -2, so that x-intercept is extraneous. It doesn't actually work because of this initial restriction. So if we eliminate the restriction from the get-go, we're not going to get that restricted value. Yes?
Why is x plus 3 not a vertical?
Because it's on the top. 0 on the top of the fraction's all good. It's only denominators that give us restrictions. You can take 0 divided by something. You just can't take something divided by 0.
So what do you do after you get the holes? Like, you get the holes in the vertical thing, and what do?
You graph the vertical asymptote. The whole we're not going to be able to graph until we use our calculator. So let's put a note by that says use calculator for location.
After you get, like, say, okay, we're 6, then what do you do? What's the next step?
Well, I'm going to find the x-intercepts first to get the rest of our exact points, and then we're going to do the graph and put that hole there. So to find the x-intercepts, we plug in 0 for the y into our canceled form. We multiply both sides by x plus 1. And you can just say times the denom if you want to be lazy. And that gives us 0 equals 2 times x plus 3. We divide by 2. And we get 0 equals x plus 3. So x equals negative 3. So negative 3, 0 is our x-intercept. Yep. So y-intercept 0 in a number. 0 is your x-intercept, number and 0. Plug in 0 for the x, find the y-intercept. Plug in 0 for the y, find the x-intercept. So I always start with the skeletal form. Make sure you can keep those straight. So then we go to our calculator. We type in the original equation. So the 2x squared trapped in parentheses. Bless you. So 2x squared plus 10x plus 12 divided by squared plus 3x plus 2. So there's what our graph should look like, but we know we need to have a hole at negative 2. Now if I trace negative 2, what's my calculator going to tell me?
Error.
Yeah, nothing. There's no corresponding y value at that hole. But if I hit the left arrow or the right arrow, we're going to see that negative 2, negative 1.5-ish is about where our hole will be. So negative 2, negative 1.5-ish. We'll put that hole right there. So use calc for location and use the trace button. So then, sketching our graph up to the horizontal asymptote, down to the hole, and again, we're not going through the hole. That is an open space where it is not defined, and curving up and down towards the other asymptotes. And that is our graph. So that should hopefully be a good warm-up for you guys to be able to do the homework quiz. However, before we do that, just in case people work at different spots, I want to go through the rest of the things on the review so that once you guys are done with the homework quiz, you can continue working. So go ahead and turn to the first page. For 6.1, operations with rational functions, the first thing you always start with is identify the operation. What's the easiest operation to do? Multiplication for sure. Multiplication, it's pretty much just factor and cross off. Factor and cross simplify. What's tricky about division? Do we actually divide rational expressions? Keep, change, flip. And then, once it's multiplication, we factor and simplify. Adding and subtracting. What makes that operation that much harder? Common denominator first. So find LCD, creative forms of 1. Add tops and simplify. So the operation that you have, that dictates how the rest of the problem goes. Now, if it is a complex fraction, those are those big, ugly ones, you handle the top, the bottom, and then the division by doing keep, change, flip. And again, folks, these are just kind of shorthand notes. If you are not sure what some of these things mean, you can always go back and reference your notes as you are working through these. But this is kind of a shorthand of everything that happened with those operations. In the next section, 6.2, solving rational equations. When you see that equal sign, I want you to think the LCD is dynamite. We find the LCD and we use it to blow up all of the fractions by multiplying through by the denominator. The other tricky thing with solving, check for extraneous solutions. And how we do that is we identify any restrictions on the equation first, just like we did with the graphing. And then that takes us to the last section with graphing the rational functions. And those we've pretty much already talked about all of the key features. And again, top heavy, bottom heavy, same. These exact rules will be on the board for you. So you do not have to memorize those. You just have to know what that shorthand means. Do we have any big questions before we take the graphing homework quiz? All right, let's get after it then.